Section 3.1 is called the remainder theorem and the factor theorem. We're going to start the day with kind of a review problem, but they've changed the language on you because that's what they do in math, right? They make things harder than they need to be. Given any polynomial p of x. All right, here's our polynomial p of x. It's fourth degree. Let c represent any number. To find p of c, plug in c wherever there is an x in the function and simplify. This is called direct evaluation. All right, this is what we've been doing the whole time. If it says use direct evaluation to find p of c, well, my c is a 3. So all we're going to do is find p of 3. That's all it's asking you, is to take this function, this rule, and plug the 3 in and see what you get. All they've done is they've called it a c now, and that is just really unnecessary. But we'll plug in the 3. Everywhere we see an x. Please excuse my dear Aunt Sally says to do your exponents. So I'm going to do the exponents. I'm going to take you through this math. Be your human calculator. 3 to the 4th is 81. 3 to the 3rd is 27. All right, now we're going to go through and do all the multiplication. 2 times 81 is 162. 10 times 27, 270. 38 times 3, 114. And plugging all this into your calculator, you get -4. That is nothing that you haven't already done before in this class. Taking a number and plugging it in. What you need to know is that what that is called is direct evaluation. Because we're going to change the directions on you, and you're going to have to know how to do it all the different ways. So if I say solve using direct evaluation, you are plugging in the number for x and getting your answer. Old method. All right, there's a new method for finding p of 3 that we're about to do, and it involves synthetic division. I don't want to read through all of this because it's not going to make sense to you. Let's learn by example and remember how to use synthetic division. Synthetic division is a method of dividing a polynomial, big word, things, many terms, and exponents, by a first degree binomial. I'm going to say that again. Dividing a polynomial by a first degree binomial, and your leading coefficient has to be a 1 in order to use synthetic division, so it will always be a 1 in front. Okay, someone came up with a way to divide x minus 3 into this thing and dropping the variables. What you do is you make a big L with room for 2 rows of numbers. On the inside of the L, you're going to put all of the coefficients of your variable and your constant. But we have to be careful because we have to include every exponent regardless if it's written or not. Let me show you what I'm talking about. My highest exponent is x to the 4th, and it has a leading coefficient of 2. We're going to bring down the 2. After x to the 4th comes x to the 3rd. It has a coefficient of -10. After the x to the 3rd comes x to the 2nd. We're missing an x to the 2nd term. We have to include every exponent. I'm just going to put a +0 x to the 2nd just to show you, couldn't I just put in a +0 x to the 2nd? And x to the 2nd now has a coefficient of 0. X to the 1st has a 38, and our constant comes down as well. On the outside of the house, we put the number that makes this equal to 0, the value for x that makes this equal to 0. Some of you have learned just to change the sign. If you have a -3, you put a +3 on the outside. That's fine. It's whatever makes this 0. All right, so now we have kind of written this problem with a division house so that we don't have any of the x's. We only have the coefficients. What you do is you drop your 2 and put it on the outside of the L. We multiply the 3 times 2, and we get 6, and you put it here. Inside the L, we add. Negative 10 plus 6 is a negative 4. On the outside, we multiply. 3 times the negative 4 is a negative 12. Inside the L, we add. 0 plus negative 12 is negative 12. On the outside, we multiply. 3 times negative 12, negative 36. On the inside, we add. 3 plus negative 36 is 2. 3 times 2 is 6. Negative 10 plus 6 is a negative 4. Now to get my final answer, we have to put the x's back in. These right here, this is your quotient. This is the answer to the division problem, but without your variables. We have to go put them back in. This right here is your remainder. This right here is the constant term, the plain number. This right here will be your first term that has an x. It will have an x to the first. This is your coefficient of x squared, and this will be your coefficient of an x to the third term. So we go to write our final answer. 2 is the coefficient of x to the third. Negative 4, so I'm going to take care of that with a minus, is your coefficient of x squared. Negative 12, so I'm going to take care of that with a minus, is your coefficient of x. Your constant is a positive 2. You have to put a plus 2. Now what in the world do we do with the remainder? I'm going to go back to your elementary school days. And if I ask you to divide 27 by 4, 4 goes into 27 6 times. 6 times 4 is 24. In second grade, you learned to write this as 6 remainder 3. 6 with an R, 3. That was your favorite. You loved that. It's great. Okay. We don't do that anymore. Then maybe you learned how to add a decimal and a 0 and bring up your decimal and bring it and continue dividing. Okay, that's one way. But last, you learned that you could take the remainder and put it over your divisor. Your remainder went here, and your divisor goes here, and write it as a fraction. That's the method that we are going to use for our remainder. And isn't 6 3/4 the same thing as 6 plus 3/4? So we're going to have a sign in the middle. So we come to our remainder. It's negative, so I'm going to take care of that with a minus sign. And my remainder goes over my divisor. What in the world is my divisor? It's this guy right here, the x minus 3. It's the thing I divided by. Just like 4 was the thing I divided by. Over here, x minus 3 is the thing I divided by, so it goes in the denominator. And this is the quotient when you divide this polynomial by this binomial. All right, you're going to be doing synthetic division like a bazillion times over the next couple weeks. So we're going to do several more today, but let's just recall our answer to this example. On the previous page, on page 78, we had this problem right here, and we plugged in a 3. And do you remember what we got? Probably not. We got negative 4. All right, somebody who doesn't have video games and had a lot of time to think about math figured out a different way to get negative 4 without using direct evaluation. They used synthetic division. See right here? The remainder is the answer you get when you plug this number into the, was that the dividend? The dividend. It's weird. I don't know how that works. So if you were to take this equation, which we just worked, and put in a 3 on the outside, P of 3 is equal to the remainder. We already got it with direct evaluation, but you can also get it with synthetic division and grab your remainder. And that is the answer you get when you plug a 3 into that machine. Let's do another one and see if we can get this to get clarified even a little bit more. All right, the hardest part of section 3.1 is knowing what the question is asking. This question is asking you to divide, so we're going to go ahead and get this big old nasty answer. It's asking for the answer when you divide. Okay, so we come over here, and we're going to use synthetic division. My highest exponent is a 2 with a 4 in front, so we're going to bring a 4. X to the first is missing. We're going to have to put in a 0 for an x to the first term. And then we've got our negative 8. On the outside of the house, we put what makes this equal to 0, guys. We put it what makes it equal to 0. We're putting a negative 2 on the outside. Did you put a negative 2? People either think it's the opposite of what you're given, or it's what makes it 0. We drop the 4. We multiply. We add. We multiply. We add. This is the quotient, the answer to my division problem. This is my remainder, this is my constant, so this goes with an x to the first term. And the answer to this division problem is 4x minus 8, because the 4 goes with an x, the minus 8 is my constant. I have a positive 8, so I'm going to put plus 8 over the divisor, x plus 2. That's my quotient. All right, but if I'm asked this question, this is a completely different question, but the math is the same. The math is exactly the same. Given this function, find p of negative 2. If you were to use direct evaluation, you would plug in the negative 2. And I know everyone in the room is thinking, that's so much easier. I get it. I get it. But there's another way. You can do synthetic division, put a negative 2 on the outside, and here, p of negative 2 is equal to 8. How did I know that? Because it's the answer for the remainder. But again, the hardest part of this section is these are two questions where the math is the same, but you need to be able to differentiate which question is asking for what. This question, p of negative 2, is asking for a number. It's asking for the remainder. The divide is asking for the quotient. Okay, so what we have just done is we have actually done the remainder theorem. If you divide a big old long polynomial by a first degree binomial, then the remainder is equal to p of c. If you plug c into the machine, the remainder is what you get. So this is where the directions come into play. Given this, find p of 2. Given this rule, find p of 2. It's going to take everything in you not to plug in a 2 right here. You may do that to check your answer, but it says use synthetic division. It also might say use the remainder theorem. If it says use synthetic division, use the remainder theorem, and you plug in a 2 right here, I have to count it wrong, guys. You haven't used the remainder theorem. All right, the remainder theorem says synthetic division. Our highest exponent is to the third, and it has a 4 in front. So to the third has a 4. To the second has a negative 1. To the first has a negative 8. Do you see we're missing a constant? We're going to have to put a 0 in the constant's position. On the outside of the house, here's a common mistake. A lot of people want to put a negative 2 on the outside of the house. I get it. We just talked about changing the signs. But you put a positive 2, guys. You only watch the signs when it's written as a binomial. When it's just written as a number, that's the number that goes on the outside. We drop. Multiply. 8. Add. 7. Multiply. 14. Add. 6. Multiply 12. Add. 12. P of 2 is equal 12, I got it because that's the remainder. That is what you would get if you took 2 and plugged it in here, here, and here. It's the same thing that you would get. All right, I think we've got one more of these before we change to the factor theorem. So let's just do one more. All right, use synthetic division or the remainder theorem to find p of -4. All right, let's go with it. To the third power is my highest exponent. It's got a -1. To the second power, +5. Do you see x to the first is missing? Got to put in a 0. Constant, -1. On the outside of my house is a -4. When it's just the number, you grab the number. If there's an x with it, you watch the sign. We drop. Multiply. Add. Multiply. Add. Multiply. Add. My remainder is the answer. If I were to take -4 and plug it into here, I should get 143. But I got it using synthetic division or the remainder theorem. Okay, before we go on to the factor theorem, because I just kind of want to be clear, do you understand, and this is going to explain the factor theorem, that the same math problem would have been done if I asked you to divide by x plus 4. Do you see it? If I had asked you to divide this by x plus 4, I would have done the same math. This is when you change the sign. This is when you leave your number alone and just put it on the outside. Are we clear on that? All right, the factor theorem has to do with the idea of switching back and forth from here. Okay? Let's remind ourselves what a factor is. A factor of a number is a number that goes into something evenly. The factors of 36. 1 and 36, because they go in evenly. 2 and 18 are factors because they go in evenly. What number did I just say? 18? 36. 36. Okay. So I couldn't even remember COVID. I still have a little COVID brain. 4 and 9 go into 36 evenly, and 6 goes into 36 evenly. But 8 does not go into 36 evenly. 8 is not a factor of 36. Are y'all with me? Another way of defining a factor is there's no remainder when you divide. If something is a factor of something else, you divide and you get a remainder of 0. Isn't this, if p of c equals 0, then x minus c is a factor. That has to do with right here. So if p of 2 equals 0, if you put 2 on the outside of a house and you get the 0 remainder, that means it's a factor. That tells you that x minus 2 is a factor. Either one of these when you put a 2 on the outside of the house. Likewise, if p of -6 equals 0, so you put a -6 on the outside and you get a 0 here, then x plus 6 is a factor. It's okay if you're a little hazy. We're about to bring it all home in just a minute. But likewise, it works backwards as well. If x plus 6 is a factor, when you put -6 on the outside, p of -6 would be 0. That means you get a remainder of 0 when you plug in -6. And likewise, if x minus 1 is a factor, then p of 1 is equal to 0. All right, let's see if I can make all of this make sense with an example. Okay, down here, it says, use synthetic division to determine if the binomial is a factor of the given polynomial. Let's stop there. Use synthetic division to see if this is a factor of this. It's asking, does this go in here evenly? We're looking for 0 as a remainder. Let's not read the rest of the problem. Let's just do this one step at a time. This right here tells you what to do. Even if you don't know what's going on, it says use synthetic division. All right, x to the third has a 1. X to the second, -3. X to the first has a 6. And my constant is a -8. Oh, yay, we didn't have to put in any zeros. On the outside of my house, I will put a +2. It's written with the x. We have to watch it's what makes this equal to 0. We drop. We multiply, 2. We add, -1. We multiply, -2. We add, +4. We multiply, 8. We add, we get a 0. I'm going to put a little smiley face in my 0. That tells me when I divide this by x minus 2, there's no remainder. That tells me x minus 2 goes into this evenly. Okay? Now, before I get to the next set of directions, let's just take 28 divided by 7. 7 goes into 28 4 times. Remainder 0. Doesn't that mean that I can take 28, my problem, and make it equal to 7 times 4? These two things multiply to give me a 28. That's what we're going to be doing in the next little set of directions. It says if it is a factor, which it is, smiley face, it's a factor, it goes in evenly. Write P of x, all right? P of x. Represents this big old long thing. This big old thing as the product of the factor, x minus 2, and the quotient. That's this part right here. This is my constant. This is an x to the first term, and this goes with an x squared. X squared minus x plus 4. Write it down, and then I'm going to talk you one more time through what we just did. If it's a factor, write P of x as the product of the factor and the quotient. That's what we did over here. We wrote 28 as a product of the factor, and the factor was 7, and the quotient was 4. Quotient is the answer to your division problem. So you take your factor and your quotient, and you can multiply them together, and it's going to equal that big thing. Right there. This right here, WebAssign calls the reduced polynomial, just so that you'll know what they're talking about. So you can take your answer and write it as a product of the factor and the reduced polynomial. Let's do one more and see if everything gets clarified. And if not, I will be happy to take your questions. All right, use synthetic division to determine if C is a 0. They changed some language. C is a 0 of the polynomial. If C is a 0, write P of x as the product of x minus c and the reduced polynomial. All right, well, even if you don't know what the question is asking for, again, use synthetic division. That gets you started, right? So we know we need to use synthetic division. X to the fourth has a 1 in front, x to the third has a 1 in front, x to the second has a -21, x to the first has a -1, my constant's 20. Here's our biggest error. On the outside, am I putting a -5 or am I putting a +5? When it gives you the number, you just put the number. When it gives you an x with it, you watch your sign. We drop. Multiply, -5. Add, -4. multiply positive 20, add negative 1, multiply positive 5, add 4, multiply negative 20, add 0. We got it. We got 0 right there. That means that when they give you the number, we're going to have to change it to its factor. The factor is x plus 5. Do you see it? This is the same problem. It would still ask you to put a negative 5 on the outside. I can take my big old long p of x. Leave some room, guys, because I have some great news. Okay. I can take my big old p of x, this whole long thing, and I can write it as x plus 5, the factor, times the reduced polynomial. This is my constant. This would go with an x to the first. This would go with an x to the second. And this would go with an x to the third. The reduced polynomial is the quotient, that is x to the third, minus 4x squared, minus x plus 4. For right now, for today, that is your final answer. That is your final answer at this moment right now. However, what we're working towards is me giving you this and me saying, factor the whole thing. Or me saying, find all the zeros, also known as x-intercepts. All right? So I want you to write this because it's important. But for today's lesson, you are done. But how many zeros is this guy going to have? How many x-intercepts is this going to have? 4, right? We look at the highest exponent. It's going to have 4 zeros. We can get all of them today. We know enough to get all of them today. Do you see this right here? Y'all can factor that. It's got 4 terms. We know how to factor 4 terms. We group them. All right, let's group them. These guys have an x squared in common. That would leave you with an x minus 4. Bring down your minus sign. These guys don't share anything in common, but you remember when you're grouping, you have to take out the 1. And because I took out a minus 1, it's going to change my sign to x minus 4. Now they share this x minus 4 in common. I'm going to bring it to the front and put my leftovers in back. I'm looking here. I see a difference of squares. That is an x plus 1, x minus 1. I'm going to bring down the x minus 4. And don't forget, at the beginning of the problem, we had this x plus 5. Do you see what you've done? You've just factored this 4th degree 5 term, this heinous thing. You've just factored it down to here. Do you see your x-intercepts on this graph? Negative 5, positive 4, negative 1, and positive 1. That's where we're headed with this unit, is me at the end of the unit giving you a 6th degree giant long polynomial function and you getting it down to where it's factored and you can give me the x-intercepts. So, pretty cool stuff.